All right, so now that we are a little familiar with what the quadratic formula looks like, let's use it. So our first example, how can you use the quadratic formula to find the solutions of x squared minus 7 equals 4x? All right, so here's a quadratic equation. X squared equations where 2 is your highest exponent is a quadratic equation. So we can use the quadratic formula to solve this. When we use the quadratic formula, we do need our equation in standard form, which means we want standard form, all the terms on one side set equal to 0 on the other side. So this 4x, we're going to go ahead and subtract 4x from both sides. And when we rewrite our equation in standard form, the x squared term goes first. That 4x term would go second, so minus 4x minus 7 and then equals 0, because the 4x minus 4x gives us 0 on the right side. So we need our equation to look like this before we can do the quadratic formula. When we use the quadratic formula, we have to identify the a, b, and c values. Our a value is the coefficient of x squared, which is just a 1 right here. The b value is the coefficient of x, so our b is a negative 4, and our c value is the constant term on the end, that negative 7. So why don't we'll just run through what the quadratic formula is again. We just heard the song for it, so you can even sing along with me as we write this out. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Look how easy that was. Okay. Oops, and I forgot 4ac. I think I sang it but didn't write it down. So really, all we do is we plug in our values for a, b, and c and simplify. That's all it is. So it's not super challenging. It can get a little tedious, but we can handle a little tediousness, a little tedium. What would we call that? All right, so here's our formula. X equals, we have a negative b. So I always put the negative, then a parenthesis. Then I look at the b value, it's a negative 4. So I write a negative 4. If your b value is negative, we do end up with this double negative right there. We'll deal with that when we simplify. The rest of our formula, plus or minus the square root. Now we have to do b squared. When I plug that in, parentheses around my b, really we're putting parentheses around every value that we plug in. So b squared minus 4ac, so 4 times our a is 1, our c is negative 7. All over 2a, so plug in a 1 for your a. All right, so where do we begin simplifying this? Well, why don't we take care of this double negative? That negative 4 does turn positive. So we have a positive 4 plus or minus the square root of something. So we are going to figure out what this number is. Grab your calculator, use parentheses, and you can just type that in exactly as we wrote it. If you type it in exactly like this, you will end up with the right answer. When you do type that in, you get a positive 44. All over 2 times 1 is 2. So already it looks much better. We took this whole thing and we got it simplified this far. After that, we're going to address the square root. In this case, we're taking the square root of 44. 44 is not a perfect square, so we can't take the square root of that. So we will go ahead and reduce the square root. Square root of 44 is the same, it can be rewritten as square root of 4 times 11. We know the square root of 4 is 2, so, all right, I kind of didn't give myself space for this. I'm going to carry down our 4 plus or minus. Square root of 4 times 11, square root of 4 is 2. And that square root of 11 stays under the root, so that's a 2 root 11, all over 2. All right, we can simplify this one more step. What we notice is we have two terms, the 4 and the 2 root 11, that are both being divided by 2. If those actually will divide by 2. Let's separate or continue a little bit further. 4 divided by 2 is 2, plus or minus, and then 2 root 2 divided by 2, or 2 root 11 divided by 2. We would divide those 2. The 2 divided by 2 is 1, leaving us with just a root 11. So this actually is 2 answers, 2 plus or minus square root of 11. You can leave it like that, but let's also recognize that one solution is 2 plus square root of 11. The other one is 2 minus square root of 11. So you could separate it out and give those values for x as well. If we remember when we solve quadratic equations, we are finding x-intercepts. So if you were to graph this parabola, we would be crossing the x-axis at those 2 spots. Okay, now that we have talked through it thoroughly, we can run through a couple more examples a little bit faster. Part A, we want to get this into standard form to solve. So I'm just going to take that x squared and subtract x squared to get this to the other side. I'm going to rewrite our equation, negative x squared. I want the x term second, so minus 4x. That 21 is positive, plus 21 equals 0. So I got everything to one side and rearranged kind of all in one step. Now let's identify our a, b, and c. A is the coefficient of x squared, which is a negative 1. B is the coefficient of the x, negative 4. And c is the coefficient, oh, it's not the coefficient, it's the constant term on the end. All right, we've got our a, b, and c identified. Now we can plug those into our quadratic formula. So x equals negative b, so negative parentheses, plug in your b value of negative 4, plus or minus the square root of b squared, so negative 4 squared, minus 4ac, so minus 4 times plug in a negative 1 for a and a 21 for c, all over 2a. All right, we simplify first by doing that negative 4 turns positive 4, plus or minus the square root of. We type that into our calculator to see what we get. And as long as you promise me that you will use all of those parentheses and type it in exactly as we wrote it, then I will let you use your calculator. When we do that, we get 100. That's all over 2 times negative 1, so negative 2. All right, next up, let's go ahead and see what we can do with our square root. Now 100 is a perfect square, so square root of 100 is 10. So we'll replace that with a 10, 4 plus or minus 10, all over negative 2. All right, so from here, we're going to get our 2 separate answers. This 4 and this 10 are like terms, so we can actually do 4 plus 10 and 4 minus 10. We'll take that value and divide it by negative 2. So what I like to do is I kind of like to branch it out. I'm going to do 4 plus 10, divide that by negative 2. Well, 4 plus 10 is 14, divided by negative 2 is negative 7. There's one of our solutions. Down below, I'm going to do 4 minus 10, divided by negative 2. I do have to simplify the numerator first. 4 minus 10 is negative 6, divided by negative 2 is a positive 3. So x equals negative 7, positive 3. All right, we've got another one. I'm going to have to move this over. Hopefully you guys are writing smaller than I am. Part B, x squared minus 2x equals 24. Let's get standard form set equal to 0, so we're going to subtract this 24 and rewrite x squared minus 2x minus 24 equals 0. We'll identify our a, b, and c values. So a is 1, b is negative 2, c is negative 24. We're going to plug those into the quadratic formula. So x equals negative b, so negative negative 2, plus or minus the square root of b squared minus 4ac. So here's our b squared minus 4 times a times c all over 2a. Okay, so first we have this negative negative 2 that's going to turn positive, plus or minus the square root of something. So we grab our calculator, we type that in with the parentheses, and we actually get 100 again. So that's fun. I would have thought that would have been different for a variety, but that's okay. All over 2 times 1. Now let's see what we can do with our square root value. That's a perfect square, so we'll go ahead and take the square root, and we have 2 plus or minus 10 divided by 2. That's where we will break this apart, and the reason why we're doing that is the 2 and the 10 are like terms, so we can continue to simplify this. We're going to do 2 plus 10 divided by 2. 2 plus 10 is 12 divided by 2. One of our answers is 6. And then 2 minus 10 divided by 2. 2 minus 10 is negative 8 divided by 2 is negative 4. So our solutions are x equals negative, it doesn't matter which one you write first. Negative 4, positive 6. Okay, this has gotten to be a long video, but you guys are still with me, so thank you for listening. What is the maximum number of solutions the quadratic formula can give? So the answer to that is 2. 2 solutions, that's the maximum number that we can get from the quadratic formula. Here's why. The quadratic formula is used to solve quadratic. Oh, this is the sloppiest handwriting. Good thing you guys are listening. Are used to solve quadratic equations which have at most 2 solutions. Remember what this looks like on a graph is your parabola crossing the x-axis. The most number of times that a parabola will cross the x-axis is twice. So that is the maximum number of solutions the quadratic formula will give us.